Okay, welcome back. We're continuing on with Unit 6. This will be our last lesson for the unit. We're going to be continuing with factoring, and right now we're going to be looking at a form of factoring uh, called sum and product when we're dealing with something called a simple trinomial. So this is where we're going to try to use our greatest common factor method that we learned in 7.2. We're going to try to use our difference of squares method that we learned in 7.3. But we're going to see that none of those methods can work, so that we're going to learn this new form of factoring. So this new form of factoring is going to work when there are three terms that are given. And now remember, terms are anything in an equation that are separated with plus or minus signs. We're also going to have a 1 in front of our leading coefficient, our highest degree, that x squared. We got to see a 1 in the front. And that 1 is going to make it a simple trinomial. It's also going to make it that we can't use greatest common factor. And when it has three terms, we also know that we can't use a difference of squares because a difference of squares can only have two terms. So if we look at this example right here of x squared plus 8x plus 12, we can see that there's a 1 in the front here. Now, if we try to use this method of greatest common factoring, 1, 8, and 12, the smallest number is 1. So we could try to take a 1 out. We could say, oh, we're dividing all of them by 1. But if we divide 1 by 1, does it change? It's still a 1. If we divide 8 by 1, it's still an 8. If we divide 12 by 1, it's still a 12. So taking out a 1 is not an option for greatest common factor. We can't do that. It doesn't make any sense. It doesn't change the equation. And if we look at our x's, we have 2x's, 1x, and no x. So with that method of greatest common factoring, we have no x to take out, we have no number to take out, so no greatest common factor. And we also have no ability to use a difference of squares because there are 1, 2, 3 terms that are separated with plus or minus signs. So that's why we're going to learn this new method of factoring. So here's what we'll do. It gives you all the explanations off to the side here, but ultimately I'm going to try to explain this in a better way. We're going to use a method called sum and product. I think that's the easiest way to teach this form of factoring. Now, this word sum means addition, sum, adding two numbers together. Product means multiplication, multiplying two numbers together. And we're going to turn this method of sum and product into a chart. And we're always going to label this chart sum and product in that order because our sum comes first and our product comes last. And what I'm going to do is always write down the sign with the number. So positive 7 is our sum, positive 10 is our product. Now you're asking me right now, what about this 1? Well, 1 doesn't change anything. 1 times 10, 1 times 7, it's still the same thing. So we're not going to worry about it. So right now our sum is going to come from our middle term and our product is going to come from our last term. Now, with this method of sum and product, you're going to pull out a multiplication table. You're going to Google multiplication table. And you're going to look at all the ways that you can multiply. This is your first step. All the ways that you can multiply to make a 10. So we can do 10 times 1. And now we'll try to add 10 and 1. Those two numbers. Well, I know that 10 times 1 is 10. And 10 plus 1 is 11. So does it work for my product? Yes. Does it work for my sum? No, because the sum that I want to make is a 7. So 10 and 1 are no good. What other two numbers multiply to give me 10? 5 times 2 is 10. 5 plus 2 is 7. So do these two numbers work, 5 and 2? Yes. Because I want to make a 7, I want to make a 10. The two numbers that satisfy both sides of sum and product method are 5 and 2. Now for the easy part. Whenever we're factoring with this method of sum and product, we're going to go back to the top here. We're going to make two brackets. We're always going to write x first. And then we're going to fill it in with our numbers that we solve for. And it doesn't matter the order that we put these numbers in, okay? So I'm going to put positive 5 first, just because I wrote it first, and positive 2 second. And we're done. That's sum and product. Now for this method to really make sense, we're going to do multiple examples here, okay? And every time, I know I have multiple examples with different letters here, M, C, W, and D. I'm always going to just write in X because X is the easiest letter that I can write in. Sometimes my other letters get messy, right? So we already did A. Let's look at B here. We got M squared plus 6M plus 8. Off to the side, sum, product, you're going to make a chart. And we're going to write down what our sum is, positive 6. And we're going to write down what our product is, positive 8. Now already, I can come down here and write my two brackets in, put X at the front, and then I can begin to solve, right? Because then I know it says M, but again, I like to write X because it keeps it simple, okay? So now let's go look at our product side first. And we're going to look at 8. What two numbers make an 8? All right, we're going to try 8 times 1. 8 times 1 is 8. 8 plus 1 is 6. No, it's not. It's 9. So it doesn't work. What two other numbers multiply to give me 8? How about 4 times 2? 4 times 2 is 8. 4 plus 2 is 6. So then I get my sum, I get my product with the numbers 4 and 2. Does it matter the order that I write them in into my brackets? Absolutely not. So it's a positive 4 and a positive 2. Now, every time that I'm dealing with positive sums and positive products, it's really easy, as you can see. But what about if I look at D right now? D is a little bit more tricky. If I write down my sum and my product for D, my sum is negative 2 and my product is negative 15. Now here's where we have to know our sign rules. When we multiply, if we have two negative numbers, when we multiply, it'll equal to a positive. A negative and a positive is a negative, and a positive and a positive is a positive. So the only way to make a negative number when we're multiplying is to have one of them be a negative and one of them be a positive. Now, I'm not worried about those signs yet. I just know that right now, to make this negative 15, one of the numbers, when I find them, is going to have to be a negative. The other one is going to have to be a positive. So let's look at our multiplication table right now. What are the two numbers that make a 15? You could do 15 and 1, of course. But 15 and 1 are not 2 apart if I'm looking at my sum side. So I got to think in terms of what two numbers are 2 apart. And we'll make a 15. Well, how about 5 times 3? 5 times 3 is 15. They're 2 apart. And it could probably be a sum of 2. But how do we determine which one will be the negative and which one will be the positive? Well, obviously, if we're making a negative number on our sum side, our bigger number has to be a negative. And a lot of us can do that. Great. Keep doing that. But the easiest method or rule that I can teach you right now is that whatever the sign of the sum is, so see that sign right there of the sum? It's a negative. It goes with the bigger number. It's not that the bigger number is always going to be a negative. It's just that the bigger number gets the sign in front of the sum. So if this was a positive 2, guess what this 5 would be? A positive 5. But it's not, right? They're negatives. So this negative 2 makes that 5 a negative value because the bigger number is going to be a negative, so that when I do my sum, it'll be a negative number. So going back to the product side, if you're trying to make a negative, that means the 5 will be a negative, the 3 will be a positive. And then we're going to go test that. What's negative 5 plus 3 on your calculator? Should say negative 2. So because it makes a negative 2 and a negative 15, that means that my two numbers that work are negative 5 and positive 3. So now when you come back over here and you want to write in your brackets, you're going to do the same thing with x in the front, but now you got to be careful with your signs. It's not positive 5, it's negative 5. It's not negative 3, it's positive 3. So this is where it's going to get tricky with sum and product, is with our signs. Okay, we're going to use our calculators, we're going to practice this, and it'll become easier as time goes on. Now, let's go back and look at another example, an easier example like C. Again, we're changing these to x's, okay? So, sum and product. Sum of 8, product of 12. What two numbers multiply to give you a positive 12? 12 and 1. But a 12 and a 1 are not 8 apart, or they don't add up to be an 8. What other two numbers make a 12? A 6 and a 2. So we can try 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. Cool, we found those numbers right away. Of course, because they're both positives, it's pretty easy. So we're going to write down our x first, and then our two numbers are 6, positive 6, and positive 2. Okay, let's look at another tricky example here. Sum and product. I've got negative 1 as my sum and negative 2 as my product. Now we've got the negative sign, so we've got to think again. One of them is going to be a positive, one of them is going to be a negative. What two numbers multiply to give me a 2? I'm not worried about the signs, I'm just worried about the multiplication table here. The two numbers that multiply to give me a 2, there's only one option there. It's 2 times 1. 2 times 1 is 2. And I can see that a 2 and 1 will be a 1 apart, which is that sum side. Now, what's the rule that I taught you before? You go look at your sum, and you go look at the sign. So this sum has a negative sign. So that negative sign is going to go with the bigger number. The smaller number will get the positive, because negative 2 times positive 1 is negative 2. And negative 2 plus 1 is negative 1. We're done. We just got to fill it in now. X minus 2, x plus 1. See those negative signs? How we're going to work with them? Let's see another example here. Sum and product. We're going to make a positive 2 and a negative 8. So I know that I'm making a negative number when I multiply. So that means that one of them is going to be a negative. So how are we going to make an 8? We could do 8 times 1, but that's not 2 apart. Or we can do 4 times 2, because that's 2 apart. So 4 times 2 is 8, but you want to make a negative 8. So I know that one of those numbers has to be a negative sign. So now the rule that I taught you, take the sign of the sum, which is a positive, and it goes with the bigger number. So if the 4 is a positive, guess what that 2 is going to be? A negative. Because now 4 times negative 2 is negative 8. And 4 plus negative 2, which is basically 4 minus 2, is positive 2. Check that on your calculator. Make sure that you're able to get these numbers, okay? Then we're going to come in, x, it's a positive 4. X, and it's a negative 2. That satisfies my sum and product. Now let's look at another example that could be a little bit of a trick here. Again, change it to x's, okay? So we'll write down our sum and our product. Our sum is positive 6, and our product is positive 10. What are all the ways that we can make a 10? We could do 10 times 1. 10 times 1 is 10. 10 plus 1 is 11. So that doesn't work. What's another way to make a 10? 5 times 2 is 10. 5 plus 2 is 7. So that doesn't work. Are there any other numbers that I can use to multiply to make a 10? No. So this question right now, if you can't do it, again, look for the trick of it being worth 1 mark, as we discussed before. It's not factorable. You have to write that down if that's the answer. Okay, let's look at another example here. Sum and product. We've got a -4 and a -21. Okay, cool. This is going to be a little bit tricky right now because now we're dealing with the negative signs. Let's not worry about those signs though. Let's just worry about the 21. Look at your multiplication table now. What two numbers multiply to give you 21? When I look at my multiplication table, I can see 7 times 3 will equal a 21. Now you want to make a negative number, so you know one of those has to be a negative. It's not eeny, meeny, miny, mo. You go take the sign of the sum. In this case, it's a negative. And you put it with the bigger number. And then that means that the other number gets the opposite sign. So that'll get the positive. And now -7 plus 3 is, of course, -4. So the two magic numbers that work for us are -7 and +3 that make a -21 and a -4 for my sum. X minus 7, x plus 3. Does it matter the order that you write these numbers in? No, it doesn't matter. So if you wrote +3 first and -7 second, cool. It's still the same answer. Let's keep going here. Let's look at I. Sum and product. -3 and -4. What are the two numbers that work? Well, I could try 4 times 1. 4 times 1 is 4. Sign of the sum, which is negative. So the 4 gets the negative, the 1 gets the positive. -4 plus 1 is -3. So those are my two numbers right away. I could have tried 2 and 2, but 2 and 2 wouldn't have worked. And here's why I know already, as a teacher, why 2 times 2 won't work. In my head, 2 plus 2 is 4. 2 minus 2 is 0. So the only two sums that I can get are 4 and 0. I can never get a sum of 3 with a 2 and a 2. But I know that a 4 and a 1 can either be a 5 or a 3. So that's why I chose to do that first. You see that? That's where we're going to get to, okay? So x minus 4, x plus 1. Let's keep going here. The more examples we see, the better we'll get at it. Sum and product. What's the sum? +2, correct. What's the product? -24, correct. Now when you see that negative number for your product, you know that one of them is going to be a positive, one of them is going to be a negative. It's not eeny, meeny, miny, mo. It's whatever the sign of the sum is, goes with the bigger number. Let's worry about making a 24 right now. What are the two numbers that make a 24? Let's 12 times 2. That's 24. Let's take the sign of the sum, which is positive. Let's put that with the bigger number. The 2 gets the negative. 12 minus 2 is 10. Does 12 and 2 work? Absolutely not. Let's try another number. How about 3 times 8 I can see on my multiplication table. 3 times 8 is 24. The bigger number gets the positive sign. That means that the 3 will be the negative. So what's 8 minus 3? Which is that 5. So far we haven't found any numbers that work. But there's one more option on your multiplication table there. Can you find it? That's right. 6 times 4. Now, by looking at all the examples on my multiplication table, here's what I was trying to tell you earlier. A 12 and a 2 can only be a 14 or a 10. Can't be a 2. An 8 and a 3 can either be a 5 or an 11. That can never work to be a 2. But a 6 and a 4, can you see it? A 6 and a 4 can either be a 10 or a 2. So for us, it's going to be that 2. This number, 6 and 4, these two numbers, they are going to work. But if you need to, with trial and error, write them down, okay? Don't panic. So our rule is the sign of the sum, that positive, is going to go with the bigger number. That means that 4 is going to get a negative. 6 times negative 4 is, of course, negative 24. And 6 plus negative 4, which is 6 minus 4, is going to be that 2. The two magic numbers that work are x plus 6, x minus 4. Okay, let's finish this off with two more examples here. Let's see what's going on. Let's make sure that we understand this. Sum and product. A negative 5 is our sum. Product is negative 14. What two numbers make a 14? How about 7 times 2? Can a 7 and a 2 ever become a 5? Yep. It could become a 5. 7 minus 2 is 5. Or it could become 7 plus 2, which is 9. So we can either make a 9 or a 5. We're going to try to make that 5, right? So 7 and 2 are going to work. Let's make them work. We know that we got to make a negative number with our product. So one of these numbers is going to be a negative. The other one's going to be a positive, sorry. Let's take the negative sign because that's what my sum has. It has a negative sign. It goes with the bigger number. The smaller number here gets the positive sign in this case. So that's negative 14. Negative 7 plus 2 is negative 5. Those two numbers work. We'll go in and write them in. X minus 7, x plus 2. Now let's see our last example here. See if we can do this one on our own here. Sum and product, positive 4 and negative 12. Stop the video now and try to come up with the two numbers that work. Okay, the two numbers that worked were 6 times 2, which is a 12. You want to make a negative, so we're going to take the sign of the sum. This time it's a positive. And we're going to put it with our bigger number. That means that the 2 is going to get the negative. 6 minus 2 is 4. The two numbers that you should have found were x plus 6, x minus 2. You need to be careful with your signs. Okay? So right now that concludes the last lesson of the unit. There'll be homework that will be assigned and then a unit test at the end.